Hi guys, welcome to the part 2 of our mega projects. Forget everything you know about construction. In the next 2 decades, the world's most powerful nations are investing over $500 billion. Humanity has always been driven by a profound desire to build, to create, and to reach beyond the known horizon. We look at the world around us, identify its most difficult problems, and dare to dream of solutions on a massive scale. These grand endeavors are known as mega projects. They are the pyramids, cathedrals of our modern age, requiring immense dedication over many years. They bring together vast sums of money, the brightest minds of a generation, technologies so new they barely exist outside of a laboratory. These ambitious projects are not merely about constructing something large, they are about fundamentally changing the way we live, work, and interact with our world and the universe beyond. The story of the Stargate supercomputer is a recent but explosive chapter in the long quest for artificial intelligence. Competition exploded as AI models showed astonishing capabilities. Microsoft formed a deep partnership with OpenAI. They realized reaching AGI required unprecedented compute. Stargate was born, a plan for a massively powerful data center and supercomputer. Cutting-edge computer engineering lies at its heart. A supercomputer isn't one machine, but a massive network of processors. Stargate relies on specialized accelerators, GPUs, arranged in vast racks, running in parallel to process immense datasets. To avoid overheating, the system needs sophisticated cooling, likely liquid circulation rather than air fans. Immense processing is matched by vast, fast storage, feeding data to processors with no delay. Stargate is future tech, but its predecessors already affect daily life. They help writers generate text. They help programmers write and debug code. They help scientists sift massive datasets. In medicine, AI can analyze scans. It can diagnose diseases more accurately. In manufacturing, AI helps design new products and optimizes supply chains. These changes reshape the job market, creating new AI-centered roles and changing skills for many professions. For more than 2 decades, the International Space Station has been a symbol of global cooperation and a testament to our ability to live and work in the harsh environment of space. However, this incredible orbital laboratory is aging. Its operational life is planned to end around 2030. Recognizing this, space agencies and a new generation of private companies are already planning what comes next. The next generation station is emerging as commercial outposts for science, tourism, and in-space manufacturing. Built with modern, lightweight, and even inflatable modules, more efficient, more capable, and commercially viable. Next-gen solar power and more closed-loop life support reduce costly resupply. Advanced robotics handle maintenance and experiments, freeing crews for higher-value tasks. Even now, the prospect of a new space economy drives innovation and jobs. It inspires education and investment. Looking ahead, stations become hubs for training, in-orbit construction, and refueling, turning low Earth orbit into a bustling waypoint. Well, it's exciting. More than half a century after Apollo, humanity is preparing to return. This monumental effort is led by NASA's Artemis program, a global collaboration with the European Space Agency, JAXA, and the Canadian Space Agency. A central piece is the Lunar Gateway, a small, human-tended station orbiting the Moon. Unlike Apollo's short visits, Artemis aims for a sustainable presence, using the Moon as a proving ground for Mars. The Space Launch System will carry astronauts in the Orion capsule. The gateway is modular, assembled in stages, featuring compact habitation, laboratories, and advanced robotics. Multiple docking ports support Orion, lunar landers, and supply craft. Efficient solar electric propulsion maintains its unique orbit. Commercial landing systems ferry crews between Gateway and the surface. Artemis spurs investment, innovation, and jobs worldwide. It inspires students and creates Earth-side spin-offs. We may use lunar ice for air, water, and propellant, building a sustainable foothold. Gateway and a lunar base could grow into a permanent off-world settlement. Yeah, that really could happen. For nearly a century, scientists have dreamed of recreating the power of the sun on Earth. Nuclear fusion forces light nuclei together to release immense energy. ITER is the world's largest collaboration to prove this dream can work. Located in southern France, it brings together 35 nations: EU, United States, China, Russia, Japan, India, and South Korea. The reaction occurs in a massive donut-shaped vacuum chamber called a tokamak. Hydrogen fuel is heated above 150 million degrees Celsius, creating plasma. Powerful magnetic fields keep the plasma from touching the walls. Giant superconducting magnets, cooled near absolute zero, generate those fields. Every component must survive extreme heat, radiation, and magnetic forces. ITER's goal: the first fusion experiment with net energy gain. ITER drives advances in superconductors, vacuum systems, robotics, and materials. Many innovations already benefit medicine and manufacturing. It creates thousands of skilled jobs and trains the next generation of fusion experts. If commercialized, fusion could offer clean, safe, virtually limitless energy. Its primary byproduct is harmless helium. It could cut fossil reliance, reshape markets, and mitigate climate change. Fuels from lithium and water are abundant, providing baseload power to lift nations for generations. It's really, well, quite a vision. As Europe moves off fossil fuels, it must generate and distribute massive clean power reliably. Denmark is pioneering artificial energy islands in the North Sea and the Baltic near Bornholm. Uninhabited hubs, not cities, built to collect and route power. They gather electricity from hundreds of giant offshore turbines, then distribute it to Denmark and neighboring countries. On-island transformers and converters turn AC into HVDC for efficient long-distance transmission. HVDC cables link islands to shore and to each other, creating a resilient international grid. Massive caisson-based structures fixed to the seabed to host grid hardware. Centralized connections unlock unprecedented wind scale, cutting emissions and imports. The build-out surges jobs across shipbuilding, electrical engineering, and offshore construction. A more robust grid can stabilize prices for homes, businesses, and transport. With abundant power, islands can produce green hydrogen via electrolysis, store it offshore, or send it ashore by pipeline, decarbonizing steel, chemicals, shipping, and long-haul trucking. These hubs could become clean powerhouses, backbone of an integrated, sustainable European energy system. When we place these 5 projects side by side, their differences are clear. The digital realm of AI, the vacuum of space, the heart of an atom, and the windswept sea. Stargate expands intelligence, next-gen stations, and Artemis with Gateway push exploration. ITER and Energy Islands secure clean energy here on Earth. Each demands new engineering, materials science, and computing. None achieved with off-the-shelf parts. They depend on massive collaboration, from tech partnerships to space coalitions and consortia of nations. They spark industries, jobs, inspiration, and spin-offs, from better diagnostics to efficient electronics. Together they form a mosaic. AI can design better reactors and optimize energy flows. Extreme environment materials cross-pollinate Earth and space. Fusion and offshore wind will power the data centers and factories of the future, advances in one enabling another. The promise matches the challenge, staggering costs in tens or hundreds of billions over decades, Funding blends public taxpayers and private investors, requiring political will and long-term vision. Budgets strain under technical hurdles, shifting priorities, and global downturns. Working at the edge of knowledge means setbacks and delays are often unavoidable. Fusion hotter than the sun, city block compute cooling, quarter-million-mile navigation, problems with no quick answers. Success demands extraordinary management across cultures, standards, and nations. Clear rules, transparent communication, and robust governance keep projects on track and trusted. We must weigh AI's job impacts and control, space resource rights and protection, and the footprints of fusion and wind, guided by wisdom, foresight, and equity. We have journeyed through 5 extraordinary endeavors, bold answers to our need for knowledge, clean energy, and the drive to explore. They're already changing how we live, work, and collaborate, pushing technology and inspiring the next generation. The future is something we build together, starting today. Thanks for watching. Join us in the next episode of Another Wonder.